Hello everyone. Now we're going to solve physics paper 2 February-March 2025. So number 1. The diagram shows three forces acting on an object. What is the magnitude of the resultant force acting on the object? So right now we can use the triangle method in here. And resultant force, we see like three different forces in different directions. So firstly, in the horizontal direction, right, you can see 1 Newton is going to the left, 9 Newton is going to the right, and obviously 9 Newton is bigger, so it will be to the right, and it will be 8 Newtons to the right for the horizontal motion, and for the vertical one it's just 6. So we can do like a vector diagram, and this will be the resultant force, and this is 8 in horizontal direction, and this is 6. So the resultant force will be square root of a squared plus c squared, and that will be 10 newtons. So B. Number 2, which rule defines speed and velocity? So A, distance traveled in a given direction, and speed per unit time. Now speed definition, it's this one is also wrong. This is also wrong. This is for acceleration. This is simply displacement. And B, distance traveled by unit time. Well, this is correct. And speed in a given direction. Well, this means velocity has a direction. Some is a vector quantity. So B is the correct answer. 3. The graph shows the journey of a motorcyclist. Which section of the graph shows the time when the motorcyclist is stationary at some traffic lights? So that means if it's stationary, the speed will be 0. So that's going to be C. So 4. The acceleration of free fall on the moon has 1/6 of its value on the Earth. On the Earth, an astronaut's mass is measured at 60 kilograms, and which role gives the mass and the weight of the astronaut on the Earth and on the moon? So the mass would be the same on both Earth and the moon. So it will be either B or D. And weight is so we can calculate weight for the Earth. 60 into 9.8. We get 588, which is closer to 590, so this will be the correct answer. So 5. The load extension graph is for material is shown. Which point indicates the limit of proportionality? So limit of proportionality means that it follows the Hooke's law, right? Which means the extension is directly proportional. The load given is directly proportional to the extension. So it means the graph has to be in a straight line. And A is like the part where they are directly proportional to each other in a straight line. So this will be the correct answer. 6. An object of mass 4 kilograms is moving with a velocity of 3 meters per second in a straight line. What is the momentum of the object? It's just mass into velocity, and you get 12 kilograms meter per second. C. 7. A tall cylinder is partly filled with 2 liquids which do not mix. The 2 liquids have different densities. A student measures the pressure due to the liquids at different depths. So we have 2 different liquids with different densities, so they do not mix. And which graph shows the liquid pressure varies between position P and Q? So on position P, there's only like air pressure acting, right? So it will be like a bit lower, apparently. And as depth increases, so we can say that this one has lower density. So if it has lower density, that means that will be lower pressure, right? So pressure would decrease at a lower rate. And at Q, the pressure would be the biggest, right? So I'm saying it's either A or B, and C is not possible because those are two different liquids, and D is also not possible because they can't be the same. So in A and B, P has, in A, right, P has a greater rate of increase in depth, which is not true because this is less dense, so Q would have like a greater pressure thing, so it will be B. Number 8, a tennis ball with momentum 2.3 kilograms meter per second is struck by a tennis racket. The racket causes the direction of motion of the ball to reverse. The racket exerts an average force of 1500 newtons during the impact with the ball. The racket and the ball are in contact with each other for a time of 0.0024 seconds. What is the magnitude of the momentum of the ball as it leaves the tennis racket? So now we have a tennis ball with momentum of 2.3 kilograms meter per second, and then it gets hit by a tennis racket, and it reverses the direction, and it exerts an average force and then time given. And what I see when I see those like quantities is to find the change in momentum, the impulse. Right? Impulse is essentially just force into time, so you get 3.6 Newton seconds. So that is the change in momentum. And now we need to find the original, the beginning of the momentum, right? So since it changes and causes the direction to reverse in this way, I would say this is negative 3.6. And when we add those together, we get negative 1.3, and it only asks for the magnitude. So I would say A is the correct answer. Number 9. The car is traveling at a speed of 8 meters per second. The kinetic energy stored in the car is 32,000 joules. And what is the kinetic energy stored in the car when its speed increases to 16 meters per second? So this is definitely the kinetic energy will be increased just by which factor, right? So we have this equation 1/2 v squared for kinetic energy, and because the velocity is squared, right, the factor will be also squared. What I mean is, now this we have 8 and 16, and 16 is the twice of 8, but because we have to like square the number, the kinetic energy will be increased by a factor of 4. So 32 into 4 is 128. If we round that up, we get 130. So 130,000 joules. D. 10. The sun is not the primary source of energy for which source? A. While it is the source. We get while from the fossils of for the animals, and the primary source of energy for them is the sun. And tidal, it is not the direct primary source from the sun. And the wind, because of the sun, its energy creates wind currents, and wave is also caused by that wind, so the sun is the source energy for these two as well. 11. An experiment is done to compare the rate of conduction of thermal energy in metal and plastic spoons. An ice cube is placed on one end of each spoon, and the other end is heated gently. Which row has the correct prediction and the correct explanation? This metal spoon. So one thing you need to know is conduction is much faster in metal than the plastic. So the prediction is that the metal spoon will conduct heat quicker more quickly, so the ice cube will melt more quickly on the metal sponge, either A or B, and it is because metal is a good conductor. 12. 4 students determine the efficiency of 4 different electrical devices. The teacher knows that one student has made a mistake in the calculation, which value of efficiency is not correct. So efficiency, it practically cannot reach 100%, let alone going over 100%. So this is definitely not right. So be D. And 13. A sample of gas is sealed inside a container fixed volume. The temperature of the gas is increased. Which statement explains why the pressure of the gas increases? Because the temperature increases, right? As the temperature increases, the particles, they will have more kinetic energy. They will move faster, collide with the walls more often. So what I'm describing is the answer of A. And for B, mass, it cannot increase just randomly, and mass and number, they can't do that. And the time between collisions of the gas particles increases. Well, that just means it's got slower, and then the pressure, it doesn't really depend on the collisions between the particles themselves, but with the wall of the container. So that's irrelevant. In 14, a student does an experiment to determine the specific heat capacity of a metal block. She records the following measurements. What is the specific heat capacity of the metal block? So you need to know the equation, right? C is equal to delta E. I'll just write E by MC. E by M delta T. So energy supplied is 12,000 divided by, this T should be big, it's not. Okay, so it's divided by mass. Mass is in like the gram thing, but it should be in kilograms for a SI unit, so you need to be careful about that. So we change that to 0.6, and then the change in temperature, and that is 25, so we get 800. And that will be D. 15. A metal block is left overnight in a cool, shady room. In the morning, the metal block is moved into warm surroundings. Which statement about the metal block is correct in the morning? So firstly, it is just in cool, and then it will get a bit warmer, so we get energy, right? So the internal energy of the metal block increases. Well, that's true because the temperature will increase, and that would increase the kinetic energy and the potential energy of the particles inside. So the internal energy would increase. The temperature of the metal block decreases. Well, that's a bit the opposite of what's happening, right? Because it's moved into a warm surrounding. And C, convection transfers energy throughout the metal block. Convection doesn't occur in the solid thing because the particles can't move. And the metal contracts slightly. That's not true. If it's in the hotter surrounding, then it might expand and not contract. So 16. A fixed mass of gas is contained within a sealed syringe at a pressure of 100,000 pascals. The plunger is slowly moved until the pressure is 80,000 pascals, and the final volume of gas is 50 centimeter cube, and the temperature of the gas does not change. What is the volume of the gas before the plunger is moved? So this is just testing the constant thing, right? The relationship between pressure and volume. We know it as PV is equal to constant, or P1V1 is equal to P2V2. And if we do that, so this will be some kind of constant K. So firstly, we have this much, and then this much, 100. Never mind, I'll just pressure is this much into initial volume, this one, and then 80 into final is 50. So if we want that, we will 80,000 into 50 divided by 100,000. So we get 40 centimeter cubed. So that will be B. 17. The diagram shows the more energetic water molecules escaping from the surface of liquid water. What is this process called? This is just evaporation, right? It's just escaping. C. 18. A hot object emits gamma radiation. Which rule describes the two changes that both reduce the rate of emission of radiation? So to reduce the rate, you have to reduce the surface area and then reduce the temperature. So this is a bit intuitive. 19. The frequency of a wave is doubled and the speed does not change. So what happens to the wavelength of the wave? So we have this wave equation. V is equal to frequency into wavelength. So because frequency increases, what happened to the wavelength? So wavelength is equal to rearrange V divided by frequency. So you can see that they are inversely proportional to each other. So if frequency increases, wavelength will decrease by the same factor. So it will half. So the answer is D. 20. Which statement about ultrasound is correct? A. It has a higher frequency than the audible sound, and it is longitudinal wave. Well, that is correct. Ultrasound is something that it's beyond the human hearing range. So A is correct. Well, sound waves, they travel like in parallel direction, right? The vibration of particles and the movement of the wave, direction of the wave, they are parallel to each other. So they are longitudinal waves. So A is the correct answer. And 21. Which statement about the image produced by a plane mirror is not correct? So the image is real. It is actually virtual. You only see the image. You can't form that image on the screen, and you only see because those imaginary lines, they kind of meet together, and that's not the real image. That's only virtual. And now you can see that the images are bright, right? And same size and everything. So these three are correct. 22. A ray of light is incident on a boundary between air and water. Under which conditions is the ray of light totally internally reflected? So it's just asking about total internal reflection, and that happens when the incident angle of incidence is greater than the critical angle, and then it has to be traveling from like more dense material, more dense medium to less dense medium for that to happen. So let's read. The ray initially in the air is incident on air-water boundary at any angle of incidence. Because it says at any angle, this doesn't fit what I just said, so wrong. And the ray initially in the air is incident on the air-water boundary at an angle of incidence greater than the critical angle. Well, the second point is correct. And it says initially in the air. Initially in the air means you have to go from less dense medium to more dense, and that doesn't happen. I mentioned it's from more dense to less dense. So that will be wrong as well. And C is also wrong because it says at any angle. So D is the only left answer. 23. A convergent lens is used to make an image on the screen. which type of image is formed on the screen. Because the image can be formed on the screen, we can use from real image, and they usually from convergent lens real images, they're usually inverted. So not usually, almost, always. 23, that would be A. 24. A negatively charged rod is brought near to a metal sphere. A positive charge develops on the surface of the metal sphere closest to the negatively charged rod. So why is this? It's just attraction, right? Opposite charges, they attract. So maybe the electrons in the sphere are attracted by the negatively charged rod. So they're like, that's the opposite of what's happening, right? They have to be repelled because they're like charges. So B is correct. Let's just read downwards, right? Positive charges in the sphere are attracted by, the thing is, we don't actually have such thing as positive charges. We only have electrons. For electrons moving, and positive charges, they are just in the nucleus, so they can't really move. We say something is positive because there is a lack of negative charges, so that isn't right. So they don't actually move, only the electrons do the moving thing, and then the charges, they accumulate over time. So B would be the correct answer. 25. The electromotive force EMF of a cell is defined in terms of which quantities. So EMF is like the energy, right? The energy taken to like move a single charge around the circuit. So I just said the definition, so we can just match. So power, energy, power things are incorrect. Energy transferred by the cell in moving charge, moving charge around the circuit. So 25 would be A. So 26, a resistor of resistance R is connected to a battery of electromotive force EMF V. There is a current I in the resistor. Power P is dissipated by the resistor. In time T, the energy transferred is E. Which expression is correct? Well, this is just testing how well you know the equations. Well, energy is actually power into time, right? So power is defined by I into V, so energy will be IVT. A. 27. A copper wire of length 80 centimeters and cross-sectional area 0.2 millimeters squared has resistance R. Which length of copper wire of cross-sectional area 0.4 millimeters squared has resistance R? So I hope you know this equation where we can calculate the resistance is equal to, so this is some constant, resistivity constant K, and then length of the conductor divided by cross-sectional area squared. So we can say that it is directly proportional to the length and inversely proportional to the area. So because the area increases, right? Area increases, so that means resistance will decrease. So to cancel that effect, you have to increase the resistance by increasing the length. So you don't even need to do the calculation, right? The only length that is longer than 80 is D. So you can just pick it. So 28. 4 identical resistors are connected to a battery as shown. Each resistor has a value of 128 ohms. Resistor 4 is removed. Which effect does removing the resistor have on the effective resistance on the circuit? Well, the effective resistance is just saying the total resistance, right? So because it is removed, in parallel circuits, if when there are more resistors, the resistance decreases as opposed to series connection, because when you add like more resistors to a parallel connection, there are like more ways, more branches to go through, so kind of just reduces the resistance in that sense. So we can just assume that because one resistor is out, the resistance will be increased. And if we look at the choices, and there's only one answer choice for increasing, so that will be C. But you can actually confirm with by calculating as well, but that would take more time. You need to know this formula, where 1 over resistance is equal to 1 by R1 plus 1 by R2 and so on. And notice that the R1 is actually in the series connection with the whole parallel connection. So we can actually just ignore it, because it will just be like 120 plus the resistance of the parallel connection of these three minus 120 minus the resistance of only R2 and R3. So we can just ignore them. And for this original one, we can calculate, right? 1 by 120 plus 1 by 120, and we got 1 by 60, which means the resistance is 60. Right, we have to take the reciprocal. And oh, sorry, that was after removing. Sorry, I only did for 120, 1 by 120 plus 1 by 120. So for the original, we add one more, 1 by 20, and we get 1 by 40, and take 40. So you can see that this increased by 20 ohms. So 29. The resistors in the circuit shown are identical. The reading on voltmeter V2 is 1.5 volt. The reading on the ammeter A2 is 0.5 ampere. And then A3 is 0.25. Alright. So what are the readings on A1 and V1? So ammeter is this is in like the main thing, right? These are parallel branches, so we can add these two to get A1. So it will be either C or D. And for the voltmeter V1, this is also like the total of these two, and because it's for total, right, we can just assume that this will not be like 0. This can't be 0, so there has to be something. And if we don't want to calculate, we can just choose that's different from 1.5, so we can just choose D. Well, if you want to do like some calculation though, because this is in parallel connection, right, and the current is decreased by, oh, never mind, we can just think that our voltage is equal in like parallel circuits. Yeah, sorry, so current is shared in parallel circuits, and for voltage is the same parallel circuits, so this will be 1.5. So I missed 1 point, so it will be D. 30. A wire is moved in the region between the poles of a magnet. A current is induced in the wire. In which direction is the wire moved? So because it's asking for motion, we know that we have to use the filament's right hand rule. So you can take out your right hand, put those 3 fingers in perpendicular to each other, and magnetic field, which is the finger, it has to point from left to right, and then direction of induced current, which is the middle finger, has to point downwards, and you will see that it will be perpendicular into the page. So okay, so let's just say this is B. So it'll be kind of like into the page. So it'll be C. 31. A fixed resistor is connected to the secondary coil of a step-down transformer. The transformer is 100% efficient. Okay. The variable resistor is adjusted so that the current in the fixed resistor decreases by 0.25 amperes. And what is the change to the current in the primary circuit? So because this is 100% efficient, the power they will be the same, right, in both primary and secondary circuits. So let's try some algebra, right? So according to what we know, here voltage 1, we got voltage 1 into, let's say, current 1, I1, will be equal to V2 into I2. And the current in the secondary coil decreases by 0.25, so we will do something like this. V2 into I2 decrease by 0.25, and that will be equal to V2 I2 minus 0.25 V2. So we have this, and that has to be equal to the primary coil current in primary coil. So that will be V1 into I1. We don't know like how much it has decreased, whether 0.25 or more than 0.25, less than 0.25, anything like that. So we just put D, or maybe even 0, like no change. But it will change though because the power has to be constant. So D is out, and that will be equal to V1 I1 negative, D into V1. So to make things clear, I'll have to make these two equal, because after the decrease they will be equal. So these two terms, they are equal, right? So they can be out of the equation. So you know that 0.25 into V2 is equal to some kind of difference into V1. And because V1 is bigger, it's a step-down transformer, so V1 will be bigger in the primary coil, so V2 is smaller. To like equalize this, right, D has to be smaller than 0.25 in order for these two quantities to be the same. So the answer would be decreases by less than 0.25 amperes. So 32. An electrical device changes the voltage of an electrical supply from 240 voltage alternating AC to 20 voltage AC. So what is this device? It decreases. So I think a generator generates electricity, does not decrease. Relay also does not decrease. It's just trying to operate a smaller circuit using electromagnetic induction. So that's wrong as well. So C is a transformer. Transformer does do that. Like we just saw that step-down transformer. So C is the correct answer. Voltmeter just measures voltage. So 33. An AC generator is set up so that its coil of wire is perpendicular to the magnetic field. The coil of wire is rotated slowly to produce an alternating electromotive force EMF. A graph of the induced EMF against time is plotted as the coil rotates. So which section of the graph represents a rotation of 3/4 of a turn? So we can see like 4 parts, right? 4 parts of the. This is like one full circle. This is like extra thingy. So we can see here like 4 parts, 2, 3, 4, and 3/4. So that will be R, right? So it will be. So QR is like 3/4 time, and it wants like the whole 3/4, so it will be from O to R. So C. 34. Uranium nucleus decays to form thorium by emitting an alpha particle. Thorium decays to protactinium by emitting a beta particle. So which row gives the atomic number and mass number of this isotope of protactinium? So firstly, by alpha particles, atomic number will decrease by 2, and then because beta particle, you will add 1, so the change will be -1. -1 is 91. We can just choose C. So 35. Which row shows what happens when a nucleus decays by emitting a beta particle? So beta particle is just an electron. Electrons either A or C. And the neutron in the nucleus will change to a proton and an electron, to conserve the charge. This is 0. This is +1 and -1. So C is not possible. So 36. Which precaution does not always reduce a scientist's exposure to 1. Working with sources of ionizing radiation? A. Ensuring scientist only works with sources of radiation that have long half-life. So intuitively, you might think with long half-life, that would be a slower rate of radiation. Well, that is true, and it's asked for like does not always. So this is the correct answer. It's not always like completely sure whether it is safe or not. So B. Increasing the distance between the scientist and the source of radiation. Well, this is definitely one of the precautions because that this ionization may not have a long range in the air. They may not be able to travel that far, so increasing the distance and limiting the time. This is limiting exposure, so that's great. And placing a lead shield. Well, lead shield can like absorb those harmful radiation, so it is also useful. 37. A detector is placed near a radioactive isotope and records a count rate of 700 counts per minute, and the half-life of the isotope is 8 minutes. The average background rate is 60 counts per minute, and what is the count measured by the detector after 16 minutes? So you have to know that this thing includes the average background count rate, so we have to subtract it. So 700 minus 60 is 640, and this is like the original count rate, right? And after 16 minutes means that that will be like 2 half-lives, right? 8 minutes and 8 minutes, so that will be 2 half-life. So we divided by 2 times, so that is 320. 320 divided by 2 is 160, and 160. You have to also consider the background count rate as well, because it wants to be like measured by a detector. It's not saying solely due to from the source, so we have to add that again, and we get D. So 38. The nucleus of an isotope of nitrogen N absorbs a neutron. It then decays into an isotope of carbon C and emits X. So what is X? So in these equations, you have to know that the left-hand side, right-hand side, they have like equal number of particles. So here we have 1, 14, so 14 has to be 1, 0, 7, 6, so we need 1 here. So this is positive, so it will also be proton. Alpha particle is wrong because it doesn't have like 2 protons and 4 nuclear number. 39. The graph shows how the strength of the Earth's gravitational field varies as the distance from the Earth's surface increases. So obviously the strength decreases. Which row describes the effect that this has on the mass and on the weight of an object as it moves farther away from the Earth's surface? So the mass does not change at all, and the weight decreases because the strength will decrease. It depends on it. So 39C. And 40. A student plots a graph of the speed of different galaxies moving away from the Earth against the distance from the Earth. Using the best straight line shown on the graph, what is the value of Hubble constant? Well, Hubble constant is, so we have to know the equation. V is equal to H naught D. So H naught is just meters per second divided by meters. So it's just per second, right? It's unit is just per second. So we have to divide V, this thing, by distance. So we can take the gradient of this, maybe find a point. Okay, so this would be the best one, right? This is easy, right? 20 something and then 1, so it will be just 2.0 something. Yeah, so A fits the best. So this is the end of the paper, and good luck with your studies.